My name is Nikita Fuchs. My role is coordinating the operations between the core dev team and everything around it. A little bit of that was already presented, so we have an ecosystem of development tools and lots of other apps and wallets. Our teams are scattered through half Europe. Most of them are in Berlin, so I am too. And I joined Aeternity because Emin asked me one day if I wanted to contribute to help this thing become really great. I was actually an Ethereum developer before that. Like in both protocols, you've got smart contract languages, and I just wanted to give you a short overview about what our core devs could have come up with so far, and what the challenges are, and why it's so challenging to come up with a decent programming language on a decentralized system like on blockchain. So how many of you guys have ever seen or interacted with a smart contract? Well, looked at one. Okay, yeah, that's a decent amount. Okay, so just a brief introduction for the others. So smart contract-based protocols allow users to deploy certain kind of rules by which people can apply changes to the state of the blockchain. So in the so you can imagine like a smart contract being like some application which is deployed on the net and synchronized across all the other users. And if you want to run it, for example, and change the state of the smart contract, for example, you want to save a string or make yourself the owner of something, then you need to send a transaction and of course then pay for it, the transaction fees. This is not so easy to do right now because on Ethereum, and in our case also, the virtual machines that execute these transactions are just basic. They have a basic stack architecture. So those transactions which you send, they all have opcodes. So like basic stuff like this. And it's not really easy to come up, to build a bridge between a high-level programming language and stack-based operations, because every operation has a cost to it. So and you basically pay for it in the equivalent of real money. So for example, like every transaction costs you a fraction of Ether, or in our case, the AE. And but anyways, you're kind of limited in the things you can do in a smart contract because of obvious reasons, and storing data, for example, is pretty expensive. But every operational step costs you a little bit of a fee, and but nevertheless, thanks to our colleagues, mainly from Sweden, which are somewhere in the back over there, just hanging around with a beer and waiting. Hello, Hans. We could come up with some cool additional features, which makes the Sophia smart contract language already quite unique and advanced. And I just want to give you like a short, brief overview for any one of you who would like to choose on which blockchain platform you maybe would like to develop. To be fair, Solidity on Ethereum is a little bit easier to learn, but the Ethereum Sophia language has definitely the better features and it's safer to use. The Solidity language is statically typed, whereas Sophia is strongly typed, and but therefore you being a functional language in Sophia, you can have lists and lists of tuples and even lists of maps, which is a really cool thing to do because maps, in comparison to regular computer systems, because of the way how data is being stored in blockchain data, is really tricky to implement. But here you're kind of like free to combine whatever you want in the list. Whereas in Solidity you can just have an array, arrays of stuff of a type which you have to previously define. So you can have like unlimited sized arrays, or yeah, you just give it a size. You can trim the length if you want to, and yeah, you can have also arrays of arrays. But for some odd reason, like this means you've got like five dynamic arrays, so it's the other way around, as you might then in comparison what you might want to expect. And so the most important thing I would say from my experience from developing the smart contracts are the maps. On Solidity they're called mappings. So for example, if you set up a token contract, then the balances are stored in mappings or maps. In Solidity, unfortunately, you're quite limited in what you can do with the maps. So you define a mapping, it maps some string input to some unsigned integer. Yeah. So then you can basically define the balances of Charles equals 1, and then you can do mapping lookups. And yeah, by defining it public, you automatically get a function for balances. So you could call this as a static, non-state changing function. And whereas in Sophia, you can do lots of cool stuff with maps. You can even pass a map as a parameter, which would be unthinkable, for example, in Solidity. And maps even have various really cool member functions here. So you can yeah, do lookup, or even provide a default return value for if this lookup returns empty data. You can ask if some value is somewhere in a map. You can just delete the entry. You can return the map size. And here comes the really tricky part. Like many developers in the Ethereum world asked for it. It was necessary in many use cases, but it was just not possible. You can turn the map into a list, or turn a list into a map. In Ethereum, that's not possible because if any one of you has maybe heard about so-called market trees, how data is saved in blockchains, for example, like in Ethereum, there's no way of knowing all the entries in the map and then just combine it to a list. And this is fortunately a thing which we have. So if you want to just iterate over all the entries in your map, you can just turn it into a list really quick. Yeah, comparing for versus switch. So in Solidity, there's just the only boring thing you can do is have a for statement, which comes with some caveats. So, for example, if you just define this like that, x would be 0, then and you would just not call it an unsigned integer, but a var, then its default data type would be 8 bits. So if you want to iterate over some data which is larger than that, then your function will fail. It will never be able to end, and basically your smart contract is broken and there's no way to fix it, and you have a major fuck up probably. So yeah, it can like really become a really expensive thing, because sometimes there's lots of money managed through smart contracts, and if you need to do something really important and then you cannot like finish your for loops because of some nuancy things, then yeah, it can get really expensive. And in Sophia we don't have for loops yet, but you can recursively call a switch function, so it's just like pattern matching. So for example here, we pass a function as a parameter, it takes some type A and returns some type B, and you pass a list of something type A, and you basically you can do pattern matching here. So you take the first element, the head of the list. So this is the first element of the list, and this is like everything else. And then you put the first element of the list in the function here, and then call this function recursively with the rest of the list. And this is done here with the prepending operator, which can also be used basically to prepend function outputs to each other, right? So this is like a hacky way of using this operator to call two functions in a line, although you're not prepending anything to each other because these functions don't return anything here. So you would basically always take the first element and put it in some function, you pass it here, and it does it, until there's nothing left, so until you have everything processed here. One of the most important security related aspects is that in Solidity you can just change the state wherever you want. You can just declare anything almost anywhere and just set any variable to wherever you want in your code. And in Sophia, the state is an object itself, so it's defined by when you initialize the contract, and everything you just change about the state you always put in the contract. So you have a globally available put function, and you say put in the state, and then you basically this is what you want to define, right? And this is the data which you put in there. So here we see, for example, preparing data, and so this is basically to force the developers a little bit to first finish everything, and then take everything they have and then modify the state and write it, and not just don't scatter your state modifying operations all over your code. And that's for the basic stuff. Actually, there's really, really cool advanced stuff. I think we're gonna hear some sentences about by Ulf. Thank you very much.